Oh, hello everyone. My name is Mr. Minnick. That's my name. Math is my game. Some people call me the Math Overlord. I'm actually joined today with my favorite statistics class ever. Uh, they're all applauding because they're grateful. Um, Today we're going to look at Chapter 2, Section 1, Variables and Data, and I'm going to be playing this back to my favorite statistics class, sixth period. Now I sound like a parent, don't I? We don't have favorites, do they? I think they do. I think they do. So anyhow, it's 2.1 variables and data. The very first definition, here we go. It's a variable. A variable. A variable. So if you like to highlight stuff, highlight the word variable if you're underlining it instead. Um, so a variable. And I'm going to use a complete sentence for this. A variable is a characteristic. Is a characteristic. Is a characteristic. A characteristic that does what? That varies, hence the word variable, that varies from one, I think they phrase it, person or thing to another. Person or thing to another. Lots and lots of definitions here. Actually, there's about 5 today, I think. Let's come up with some synonyms for the word characteristic. Anybody have any ideas? Trait, yeah, 5-letter word trait. You read my mind. A trait that changes from one person to the next. What else? A feature, sure, a feature. What else? I could think of a Q word maybe. Quality, sure. A quality. So a quality, a characteristic, a feature, a trait. Something about something or somebody. So let's discuss this because sometimes it's hard to pick these out. For example, I think about engines all the time. I don't know why I always think about engines, but I learned something fascinating on Facebook today. Really? On Facebook? Yeah. Horsepower. Does that vary from one engine to the next? Probably, because if you look at a lawnmower, it says right on the engine, or right on the top of the pull starter thing, how much horsepower it makes, right? What's the average lawnmower make? I'm talking like a push mower, where you pull start them. Nobody push mows their lawn. Well, if you pull the pull starter on a push mower, right on the top of it, it usually says 6.5 HP, right? So that's on a push mower. Anybody in here know somebody who has a Corvette or a big truck or something like that? How many horsepower does a Corvette have? The new ones have what, 500, 600, something like that? So horsepower, if we're talking about an engine, with respect to an engine, horsepower is a variable. It's a characteristic of an engine that changes from one to the next. Okay. What about? So this is in respective to engines. Okay. So that's the variable's horsepower. The thing is engines. What if the thing is a person? If the thing is a person, I know that sounds weird to say, but if the thing is a person, what's one particular variable that we could talk about with people? Anyone? Age, sure. So variable, and I'm just going to say variables. Age could be one. 38, I think. What's another one? Height, sure. Height, 6'1" and 1/8. What's another one? Weight. Not everyone weighs the same. 224. I'm down 5 pounds. I'm up 5 from last year, but that's okay. So weight. What else changes from one person to the next? Yeah. Eye color. Sure. Not everyone's got blue eyes. What else? Everybody's got blonde hair in the world. No, hair color. So a lot of times when we talk about these variables, you might think, well, why are we going over so many examples? Well, on an upcoming test or quiz, you're going to be asked to name a few variables for people, for engines, for the school. What's variables about a school? What could variables be? How many students there are, the location of it, how many levels it has, what grade levels it has, how many administrators it has, does it have air conditioning, how old is it, how tall is it? Do we get the idea? Everybody okay so far? You know what I feel like sometimes? I feel like I want to have a party where you bring a candy bar. Anybody ever hear of those parties? Okay. It's a nice theme. If you ever want to have a party for somebody and you need a theme, have them bring a candy bar that reminds you of the person for whom the party is, like if it's their birthday. So we're going to distinguish between some things. We're going to talk about quantitative variables. Quantitative variables. Quantitative variables. Quantitative variables, here's a bullet point about them. They yield numerical values. Now I'm going to add something to that because just because it's numbers doesn't necessarily mean it's quantitative. There's going to be questions about qualitative versus quantitative. Just because it's numbers doesn't make it quantitative. So I'm going to add something to this. It yields numerical values for which computations such as ordering and or finding averages makes sense. For which ordering or finding averages makes sense. Now, right away, I'm going to go ahead then and talk about qualitative variable. Qualitative or categorical variables. The book, I really hate this definition. Can I say the H word? The book says it's a non-numerically valued variable. A non-numerically valued variable. So the book is almost saying, well, if it's qualitative, it's never going to have a number in it. That's almost the implication there, and that's not true. So I'm going to add an addition to this. or a numerically valued variable for which computations such as ordering and or finding averages do not make sense. I hope I didn't have a subject-verb error on the last page. For which computations do not make sense. I think I did. For which computations? Oh, I didn't use do or does. So there we go. Yeah. Did really? So I did have one. For which computations make sense? Thank you. Good looking out. For which computations make sense? There we go. Good. Thank you. I thought I might have done that after I just read that last one. So let's put this side by side. Quantitative, it's a number, and it makes sense to average it. Qualitative, it's probably not a number, but if it is a number, averaging or putting them in order doesn't make sense. So now we're going to introduce another word. We're basically going to get all these vocabulary words out of the way, and then we'll talk about some examples. Okay? Everybody cool so far? Okay. The next definition we need to talk about is data. And we're not talking about Brent Spiner. In case you don't get that joke, back in the 90s there was a show called Star Trek, The Next Generation, and there was a character on there who I think was a cyborg, robot, humanoid, I don't know. An android, thank you. And the character's name was Data, and it was played by the actor Brent Spiner. So, by definition, data are simply values of a variable. Data are simply values of a variable. So let's think about this. The variable might be someone's eye color. If the variable is somebody's eye color, the values would be red. Who has red eyes? Everybody that gets their picture taken in the 50s and 60s. Green. Who has green eyes? I do. Blue. Hazel. What's hazel? It's halfway between green and brown. Who has hazel eyes? I do when I wear brown. I have chameleon eyes. So data are simply values of a variable. So we're going to talk about qualitative variable, or qualitative data, I mean. So qualitative data, or no, do we even need to do that? No, we don't. Yes, we do. Qualitative data, sorry. Qualitative data. Qualitative data, by definition, out of the book, values of a qualitative variable. Thanks, Captain Obvious. Values of a qualitative variable. Gotta love Captain Obvious. So Captain Obvious is probably going to say that quantitative data is values of quantitative variable, and Captain Obvious would be right. Quantitative data are values of a quantitative variable. So really, I'm feeling pretty good about this because we got most of the definitions out of the way. There's just two more things we need to talk about. Actually, there's four more definitions, but they're kind of, it's Captain Obvious. How's everybody doing so far, okay? I think we need to jump to some examples. Any questions about anything up to this point? So let's just kind of recap what we got. We're talking about variables and data. So we defined quantitative variables, we defined qualitative variables, we defined data. So a variable is a characteristic of something or someone that varies from one thing or person to the next. Quantitative variables yield numerical values for which computations make sense. Qualitative variables are not numerically valued, or if they do have a number associated with them, it doesn't make sense to average them. Data is the values of the variable. Qualitative data is values of a qualitative variable. Quantitative data is values of a quantitative variable. All right, so example. Is each variable quantitative or qualitative? Question mark. Is each variable quantitative or qualitative? You ready for this? Age. What do we think about age? I am 38, 39. Oh, wait a minute. What year is this? 2000. I'm 38. Is that quantitative or qualitative? What do we think? Quantitative, yeah. Why? Because it's a number. Just because it's a number, does it make sense to order ages from lowest to highest? Does it make sense to average ages? Yes, it does. So not just because it's a number, but because it's a number and it makes sense to order and or average them is why it's quantitative. Okay? Everybody all right so far? That one's pretty cut or dry, right? Well, let's look at eye color. That's certainly a variable. It's a characteristic about people that changes from one to the next. Red, bleen, I said bleen, grew, red, blue, green, yellow. What do we think about that? It's qualitative, sure. It is qualitative. All right, what about, we talked earlier about engines and horse power. It's a number. Does it make sense to average horsepowers or to rank or to arrange horsepowers in some kind of order from least to greatest? Well, sure, we said a Corvette's certainly more powerful than a lawnmower, right? So what do we think about this one? Sure, it's quantitative. Quantitative. We'll abbreviate that with quant. Okay. So far, this seems really easy. Bless you. It'll be great if somebody, well, it won't be great, but if somebody sneezes, it'll be a great coincidence. So these next few, you might have trouble with one like this. A street address. My address is 349. Growing up, it was 755. I hear qualitative. Anybody think it's quantitative? Does it make sense to order addresses? Is one address greater than the other? It becomes a little subjective, doesn't it? If you're talking about Atlantic Street in Warren, it could be quantitative, because one part of Atlantic Street in Warren is a lot different than the other part of Atlantic Street in Warren. But we need a definitive answer. Does it make sense to average up street addresses? Does it make sense to organize or arrange street addresses by lowest to highest? In some contexts, it does, and this is one where if you made an argument that, well, it makes sense because I live on this end of the road and this end of the road's better. If you made some kind of an argument, I wouldn't disagree with you. But we're going to say that street address is actually qualitative. Okay? Even though it's a number, because it doesn't make sense to average it, and because it always doesn't make sense to order it. Has anyone ever heard of the road Mahoning Avenue, otherwise known as State Route 18? So there's going to be 15 different people that live at 789 Mahoning Avenue. Did you know that? There's going to be 15, well, not different people, different residences. It's 789 Mahoning Avenue because there's a Mahoning Avenue in North Jackson. There's a Mahoning Avenue in Austintown. There's a Mahoning Avenue in Edinburgh. There's a Mahoning Avenue in whatever township is west of Edinburgh. There's a Mahoning Avenue in Youngstown. It goes through a bunch of different areas, so a 789 and a 789. I've actually seen two addresses that are literally thousands of yards apart, like within eyesight of each other. It's the same address on the same road. So ordering doesn't always make sense. So do you see where we're coming from with that? Okay. So let's see how creative we are then. Example, name some seemingly quantitative variables that are in fact qualitative. So when we say seemingly quantitative, we mean it's numbers, but it doesn't make sense to put them in order. It doesn't make sense to average them. Who can name a variable about that? If you play sports, you ought to be able to come up with one. We're going to have a pep assembly tomorrow, and they're going to introduce the starting lineup. And they're going to say, number 4, so-and-so. Sports numbers, yeah, sports numbers, sure. Somebody's jersey number. And you might say, well, wait a minute. The smaller players wear the smaller numbers. Well, that's not always true. There might be somebody that's 7 foot tall that wears number 1. Sometimes in football, the higher numbers, I didn't play football, but I kind of understand that usually linemen wear the higher numbers, like the ones in the 60s, 70s, or 80s. And then like the quarterbacks usually wear a lower number. And special teams wear the lower numbers. And the backs wear like somewhere in the 50s and 30s and 40s. Am I right? Okay. But for the most part, in sports, jersey numbers are like that. Can anyone think of anything else that's numbers, but it doesn't make sense to order them, to average them? Yeah, good. Phone numbers. 507, blah, 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 blah. Well, okay, 898, blah, 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 blah. 872, blah, 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 blah. Does it make sense to put them in order? Well, you can put them in order, but one number isn't necessarily greater than another. Numerically, it might be, but we can't organize them based on exchange or area code, but area codes now with so many phone numbers around. There's what, 330-216-440-234-999. There's all kinds. So yeah, phone numbers is a good one. There's another one similar to phone numbers. (44288). Zip codes, sure, 44231. Zip codes. There's another one that could go either way, and I'm going to put an asterisk beside it. I know it's very frustrating. I love to go bowling. Love bowling. And I love to go skating. I love skating. It has to do with bowling and skating. Shoe sizes, sure. Shoe sizes. So you might think, well, wait a minute. With shoe sizes, there's 10s and 10 and a halves and 11s and 11. And it does make sense because some are bigger than others. You're right. Does it make sense to average shoe sizes? What's the average of a 10 and a 10 and a half? What's the average? A 10 and a fourth. Is there such a shoe size as 10 and a fourth? No. So that's why shoe sizes is a real weird one, okay? And we need to talk about a couple other variables then, speaking of shoe sizes. So is everybody okay so far? Good. Well, there's 2 more. So within quantitative variables, within quantitative variables, we have 2 subgroups. We have two subgroups. And I'll put these side by side. One is called discrete. Shh, don't tell anybody. Don't tell anybody. It's not that kind of discrete, but they use the word discrete. And we're going to go ahead and define discrete variable. So there's a discrete variable. We'll get that definition out the way. A discrete variable is a quantitative variable. A quantitative variable. A quantitative variable. A quantitative variable. Since it's a subgroup of quantitative, it makes sense. It's a quantitative variable whose possible values can be listed. Whose possible values can be listed. Earlier today in Algebra 2, we were talking about how mathematicians use El Cheapo. So the other one, whatever one's different, you might say, well, it's possible values that can't be listed, and you're kind of right. Well, what do you mean you can't list them? Well, this other one's called continuous variable. It's called a continuous variable. Continuous variable. And it is a quantitative variable. A quantitative variable. Whose possible values form. Whose possible values form. And I like the way the book puts this. It really clears it up, I think. Form some interval of numbers. Form some interval of numbers. Now, some textbooks that I've seen in the past got discrete wrong. They say discrete is a finite list. Well, that's not exactly true. It's not necessarily a finite list. It's a finite list or a list of distinct numbers that extends infinitely. And this gets into a little bit of mathematical logic debates here. It's a finite list or a list of distinct numbers that extends infinitely. That's kind of weird, and that's why we use the other definition. It can be listed. It's kind of weird. We'll clear that up in a minute. A list of distinct numbers that extends infinitely. Okay. How's everybody doing so far? Okay. Captain Obvious would say that discrete data are values of a discrete variable, and continuous data are values of a continuous variable. Do we need those definitions, or can we just skip over those? We need them? Let's write them down, because they are in the book. So discrete data are values of a discrete variable. Discrete data are values of a discrete variable. And finally, continuous data. Continuous data are values of a continuous variable. And I'll be honest with you, this is going to give you the most difficulty of anything. Whether something is qualitative or quantitative, that's not horrible. If it's numbers, it could be both, and then you got to think, does it make sense to average it? Does it make sense to order it? If it's not numbers, it's qualitative. That's pretty easy. But distinguishing these can be difficult, especially considering the fact that there's real subtle differences. Because this one, I like to think about gas. I love gas. Not the kind that you get from eating McDonald's cheeseburgers. I don't know what it is about them, but it's always McDonald's cheeseburgers and a Coke. If you wash them down with a Coke, you're, well, anyway. So let's think about gas. Example. The size of a fuel tank in any Honda powered device. Now, when I say any Honda powered device, let's think about the company Honda. I don't know if you're familiar with Honda. Honda makes small engines used on push motors. They make industrial engines used in various applications such as pressure washers, such as electric generators, like a portable generator. Honda makes ATVs. Honda makes motorcycles. Honda makes weed eaters. Honda, I think they might even make some engines for some chainsaws. Honda makes cars. So, the size of a fuel tank in any Honda powered device, is this going to be discrete, or is this going to be continuous? Let's think about that. Discrete, we said we can count that list. It's a list of things that can be counted. Continuous means it's on an interval. This is a tricky question. Anybody think they got this one? You think it's continuous. Why would you say it's continuous? Yeah. So there's going to be all kinds of different sizes, right? There's going to be, if we think about a chainsaw, chainsaws only hold a quart, right? How much? If we're putting these in terms of gallons, a quart is what, a fourth of a gallon. So let's say one's going to be 0.25 or 0.24 gallons, and another one might be 2.25 gallons, and another one maybe it's a little bigger chainsaw, it's 0.26 gallons. And then, well, then that list is going to go on, and then maybe we're going to have a lawnmower that holds a half of a gallon, and then maybe we're going to have a dirt bike that holds 1.1 gallons, and then maybe we're going to have a Honda car that holds 16.3 gallons. And we think this is continuous. I've got news for you. This is actually discrete. Even though there's going to be a whole bunch of them, we could still count all the different ones. There might be 1,000 or 2,000 or 3,000, but we could still count all those. So you might think, well, how's that possible? Well, because between the 0.25 and the 0.24, there might be a 0.241, and there might be a 0.242, and there might be a 0.243. But if you look further than that, there might be a 2.2411 in between those. But if you look between the 0.2411 and the 0.2412, chances are there's none going to be in between those. So that's not going to warrant having an interval. We could count them. Even though there might be thousands of them, we could still count them and list them all out. Does that make a little bit of sense? Okay, so let's try this next one. Example, the amount of gas in any Honda powered devices fuel tank. This is either going to be discrete or continuous. I abbreviate continuous with a CONTS. What do we got? Interval? Thank you for asking. I'm so glad. So somebody asked, what's an interval? So an interval means, in this context, there are infinitely, incrementally incrementally smaller units between each other in this set. So what we mean is, like in Algebra 2, we talked about from negative infinity to positive infinity. Okay? And then you might say, okay, well, there's this other thing, and it goes from 0 to 1. And we might use an interval like that, where it goes from 0 to 1, where it doesn't include 1 and it doesn't include 0. But the reason it has an interval is because this set has a 0 in it, and it has a 1 in it, but it has a 0.1 in it. It has a 0.01 in it. It has a 0.001 in it. And you can keep breaking them down into smaller. So there's a whole bunch of things in there that you could never, ever reasonably count all of them. Does that make sense? Good. Thank you for asking that question. So the amount of fuel in a fuel tank of any Honda powered devices tank, what do we think? Is that discrete or continuous? This is continuous. This is continuous because there could be no fuel at all. There could be just a trace amount of fuel. There could be 28 gallons. There could be 27.9999999 gallons. The deal is, when your car goes and uses fuel, it doesn't use 1 gallon instantaneously. Imagine you were driving and your fuel gauge went from full to a quarter of a tank to a half a tank, like that, like that, like that. It doesn't happen like that. It happens incrementally, and it needs that interval. Okay? Let's try another one. I love milk. Anybody else love milk? We'll get to that, what it relates to. Somebody asked, does it relate to anything other than gas? So here we go. Example. Milk containers in the world. Milk containers. I'm so excited I didn't write the ers. Milk containers. And we're going to say the capacity of. When we talk about milk containers, we're saying the capacity of milk containers in the world. So let's think about this. In America, how can you buy milk? Or milk, as some people say. You could buy half gallon, you could buy a gallon, you could buy a quart, you could buy a pint. What happens in the world? What superior system does everyone in the rest of the world use? They use metric. So over in Italy, you're going to buy 500 milliliters, or you're going to buy 1 liter of milk. They sell milk in bags too. So there's all kinds of different sizes of milk that you can get. You know what I think is the biggest paradox in the world? Is the metric system says fractions suck. But how come in the metric system they always offer sizes that are fractional equivalents of sizes that we have? You ever wonder that? Okay. So anyways, what do we think about this? Is this discrete or is this continuous? We might think it's continuous, but this is discrete. There's going to be a bunch of different sizes, but we could count or list all of them. Okay? So to sum all this up, let's go to the lobby and get ourselves a snack. Now let's get a list of continuous versus discrete. And we'll just have generic things in here. Continuous would be any kind of amount of fluid or a substance left. The amount of fluid or substance left. Okay? Usually with continuous, we're talking about any time you're doing a measurement. Anytime we're talking about measurement. So let's think about what falls under that subcategory. If we're talking about people, what would fall under that? Height. What else? Weight. What else? What about age? Where would that be? Would that be continuous? Well, I'm 28. Yeah, you're 28. And I'm 29. Yeah, you're 29. But do you go right from 28 to 29 instantaneously? No. So age is going to be here. Okay, so we're almost done here. So any kind of measurement is continuous. What about speed? Is speed a measurement? It sure is. So speed is going to be continuous. What about if we're thinking about the climate? If we're thinking about the climate, temperature, sure. Temperature, time, temperature, those are all going to be continuous. They do warrant an interval. Why? Because there's incrementally, infinitely small number of units that can happen between every step, right? Good. Discrete. Let's go back to the bowling shoes. We said the bowling shoes, arguably shoe size is quantitative or qualitative because we could order them, but it doesn't make sense to average them all the time. But we could average them if we took the mode. Or sometimes we actually could average them, and we might come up with a reasonable shoe size. So assuming shoe size is quantitative, where would shoe size fall? Shoe size would be discrete, okay? Shoe size. Why would shoe size be discrete? Well, because there's ones and twos and threes and fours and half sizes between, but you can count those. You can list those, right? So similar to the fuel tank one, it's capacities. Capacities. Even though the amount of fluid in there could be on any interval, capacities of fuel tanks, of milk containers, capacities, there are a certain number of capacities of a particular thing. And I know that's a real difficult one because, hey, it's fluid. It's fluid. Yeah, but one's a capacity and one's the measurement of, and stuff doesn't vanish in big increments. Okay. We doing all right? Questions, comments, concerns? Well, that's it. At this time, I'm going to open it up for shout-outs. Any shout-outs? The future Mr. Minnick? Who else? Ethan Milko gets a shout-out. Gabby gets a shout-out. Logan Steiner gets a shout-out. Nikki something. Mike Jones. All right, that's it. It's been real. It's been fun. Have a great day.